Okay, then we are back. So remember that on previous videos I said that um, we will start to work with Octave um, because do operation by hand of large matrices like this one. Actually, these matrices they are of order 3. They are 3 by 3 matrices. Um, and actually we can consider a large matrix a matrix of order 4 and 5, um, but um, these matrices they contain these elements with theta and alpha, and because of this do this operation by hand uh, can be very laborious, and on the middle of the operation we can commit some mistake. So I said that it was a good opportunity to start to work with Octave, and this is will be one more tool for your set of skills. So this example is the example 2.16 from the third edition of this booking that we are using. Um, on the second edition, we don't have this same example. The example 2.16 is is different from this. And I said that we will use the Octave GNU Octave environment to evaluate this operation. So is what we will do on this video. If you don't know, we have this new magazine, um, this edition Octave for Babies, where you can find on LinkedIn, and if you look for new magazine, you can find this edition Octave for Babies, and is a magazine, is a book where uh, in which we talk about how you can installate the GNU Octave environment and work with UA elements, which is user interface, and how to build a low complexity GUI, a graphical user interface. The purpose of this magazine is build graphical user interfaces, but right here what is interesting for us is this section of matrices. So right here you can learn how to do the basics. On the beginning of this magazine we will uh, find how you can install the GNU Octave environment, uh, how to do basic operations. But today for us, what is important is this section, matrices. So right here you can learn how to evaluate one by one matrix, two by one, two by two, how to evaluate basic operations like multiplication between two matrices, how to calculate the determinant, how to do operations like a transposed form of a matrix, um, also how to evaluate its inverse. But we will use on this video um, some specific content. We will use a specific comment, and because when working with the Octave environment, which is a tool for numeric operations, numeric calculus. If you want to work with cosine and sine, we have to define some specific parameters, like we have to define a, let's use this right here, in order to evaluate these matrices A and B. So right here we are considering this matrix as A and this one as B. In order to evaluate these matrices, we have to download a package, a specific package, and then we have to pass a command. This command sims data alpha, and without this command, without this package, we cannot evaluate this matrix without have to specify some parameters, like without these comments, we have to specify like the length of the axis, which for Octave is a vector, so we have to specify the vector. So is a vector t, and we have to specify its length is something like that, I think. I don't know exactly. For Octave, it will recognize something like pi divided by 4 or by 6. So without this package and without this comment, we have to specify, define the length of the axis, which the Octave recognize as a vector, and pass also a parameter. So it's something like this, pi divided by 6 or 4. It will come right here on theta and cosine of theta and sine. And also we will have to define something for the alpha. And if you want to work to evaluate these matrices without have to specify, not without specify parameters, but evaluate with these generic angles, theta, sine, theta, alpha. So we have to download this package and pass this comment. So it's what we are going to do right now. I'm already got the Octave open, and as I said to you, you can use this magazine, and right here you will learn how to download the Octave, how to start with. So it's not our goal today work with the basics. So let's start. First, if you pass the command clear all, the Octave, it will clean all its memory. So this way we are cleaning the Octave memory. Okay, now if we type the command clc, we will clean all the command window. Okay, now we got a cleaned command window, and we can start with our programmation. We just want to do operations with these matrices. So okay, first we have to download the package which contain the unnecessary information to work with these matrices without defining the length of the vector, which is the axis, and parameters like the value of the data, the value of alpha, which you have to specify as pi divided by 6 divided by 4. So let's download the package is pkg load symbolic. Okay, now we have to pass the command to evaluate the matrices with generic data in alpha. So is sims data in alpha, and as you can see is running the package. Okay, Python communication link active. SymPy v1.10.1 probably is the version of this library which is inside of the package symbolic. Okay, so these matrices, like right here, this semicolon. If we do not type the semicolon, the Octave it will run the program, and we don't want this. We want to write the whole program, and then after this run it. So the semicolon holds the line, holds the program. And right here for this matrix, we are also separating in the lines. So this is the first line, that is the second line of the matrix, and that is the third line. And as you can see, let's compare right here the matrix A. So as you can see, the first element cosine of theta is we equally right here sine of theta, and for the scalar ones 0 and 1 we have to use this sim inside the parentheses, the scalar, so sim inside the parentheses 0. Okay, so that is the first matrix, and right here the second matrix B. So as you can see, we type the whole matrix in form of a program line. Okay, so it will be more easy if I just copy this. So I will copy this and paste right here. And as I said, we have to use this semicolon at least at the end of this matrix. So the Octave holds the program and doesn't run it. And if you not use this semicolon, the Octave, it will run the program, and we don't want this. And because of this, we are able to now type to enter the other matrix. So let me copy this. Okay. Now we have entry with our matrices A and B, and now we can do operations with them. Right here we do the operation of product. We will multiply A by B, and we have to obtain this resultant matrix. So let's see what we get and compare with the result. And we will type A times B. Okay, so as you can see, we are obtaining these values. So let's compare with the matrix that we got uh, doing by hand. Right here, this 2, it means square. So it's sine square of theta plus cosine square of theta. So as you can see, we are obtaining a satisfactory result. Right here also, 0, 0, um, with the exception of this element, which is we are not getting as same on this resultant matrix, which we do with the octave, with exception of this. The rest of the elements, they are correct, and with the exception also of this signal minus sine square of theta times cosine of alpha. With the exception of this signal, the whole elements are equal with the one that we evaluate from octave. So on the book, on the third edition, this is the element that we got from the third edition. So I don't know if a error from the book or is the octave, but we are obtaining a satisfactory result. So again, is another tool for your set of skills, and we will use this further to work with transformation matrix equation, which describe the motion of a robot. So this was the example 2.16, and as I said, we will use the octave. So there you go. We also have another example that we can use as practice. This one. But this one I will work with you on other video. Um, I want to introduce to you at least one simulation of robot arm, one simulation tool. You can download this very light software, Rocksin version 1.7 from Robot Kinematic. Is a robot kinematic simulator, and is very light, and you can download it. So I'm already got right here, and you can. It has a lot of modules of robot, and we can change the angle of the links, sorry, the joints. We are changing the angle of the joints. So as you can see, we work with angles, and on other videos I will use the simulator to simulate a real situation and present to you other models of robot arm. And at this time, I've been talking about the end effector. So if you can see the pointer, this is the end effector. Right here, this is the end effector. This is one link. Right here we have a joint. So to do the motion, kinematic analysis of this robot arm. So we use kinematics, inverse kinematics equations, forward kinematics equations. So I said that forward is to know where is it, the end effector, and inverse is to know where it's going to be. So we use forward and inverse kinematics equations together to do the analysis of the motion of the robot. And so uh, we write transformation equations which describes the motion of this robot. Cool. So today on this video you have learned a bit on how to work with the Octave, and we will use more, and also with softwares now. So now you are learning practical applications, and we are only on the chapter 2 of the book, and on chapter 3 and 4 we will learn things that it will allow us to start with um, maybe programming a robot. So now um, then we will need some hardware, um, and for now we are only work with simulators, and after this we can jump on how to program a robot. Uh, for now is all. So on the next video we'll work more with the Octave and get back to the continuation of the book. We are talking about coordinates. That's it. Thank you.